I think the most powerful understanding that the Metamorphosis has is structures. You can't form iron nickel in the center of the earth or mercury just by magic, by gravity, just clumping things together. No, man. That's metal casting. That's huge amounts of metal casting. Now when I'm at work, I see some of the metal sheets and things that have these kinds of structures in them. And it all depends on what kind of material it's comprised of, you know, and how fast it cools. It says here, effects of cooling rates on page 223. Slow cooling rates in the order of 10 to the 2K a second or long solidification times result in coarse dendritic structures with large spacing between the dendrite arms. Literally what it means is that I can also tell inside of a star, inside of a meteorite, so to speak, when you slice it open and you polish it up, you can see all the structures of the material. You can see the Thomson structures, Widman-Staden structures. That's a really big word. Sometimes can't spell that word. But when you look at the crystals, you'll notice that some are bigger than others. Some are crisscrossing in different fashions. And to actually study the metallurgy of those meteorites, and I can probably determine how fast they were cooling by, you know, how large the crystals are and their actual interior, where they were located inside the core, how deep they were inside the star when it was cooling. As well, if I ever become wealthy down the road, I want to buy large slabs of that stuff, because there's some things online where they have giant olivine crystals inside the iron matrix, and they're just fucking beautiful. Like, there's nothing on Earth. I mean, sure, you can grab it on Earth, but you'd have to go a couple 100 miles down to get it out. But these meteorites are comprised of this, and to know that that's the core, or the boundary area between, you know, the liquid or the giant crystal iron nickel ball in the center of the Earth and the rocky, when it becomes more rocky and more with different elements such as magnesium and sulfur and things like that. But I'm going to study the hell out of this book, metal casting, with fluid flow and heat transfer when you melt metals down and things like that. As well, it has different other things like the machinability of different types of alloys and things like that. And it's interesting to see that, because when you're working with metal, it behaves differently based off what composition it's comprised of. And, you know, as well as rocks and minerals too, if you work with those for sculptures and things like that. Or, you know, when you're an architect and you want to place a foundation for a building, and you have a, you know, large limestone foundation, just like Florida here. Or, you know, if you have granite, if you live in the mountain regions, you know, granite would be obviously better. You know, you got to understand how that kind of rock behaves. But basically, I want to steer scientists and astronomers and geologists away from the nonsense of the fusion model, which was invented because they didn't understand what happened to stars as they evolved. They didn't realize they were giant refractory furnaces, basically. And I wrote inside here, the main philosophy on planet building is that they have refractory material being melted together in vacuum and forming planets. So they have small bits of matter just clumping together like magic and then making bigger and bigger pieces. That's their main philosophy. But they do that in vacuum. That's not correct, because you have some things you got to solve here. You got to block the heat loss when you melt down the iron and nickel into giant balls. Vacuum doesn't do that. The matter would radiate all the heat away. You have to allow for slow cooling times. You have to allow for the material to slow very coolly, or to cool very slowly. And you can't do that with vacuum, because it would just cool too fast. So it doesn't make any sense. You have to provide the fuel for melting down the iron and nickel. There's no fuel in vacuum. How the hell do you get things hot? Which leads me to the next one. You have to get the material hot enough. What mechanism in vacuum is heating material up to melt it down the size of a damn planet? There's nothing out there. But there is something out there. The solution to what they need to do is, if they have these small bits clumping together in large amounts, you have to get something that can melt it all down and place it all and make it cohesive. The only thing in outer space that can do that is a star, because that's exactly what happens. The star collects all the interstellar material that's already in there, and it collects it into material, and it makes it a large iron nickel ball, and then it takes all the rest of the material and layers it on top and forms the planet. It's easy to understand. But it's a different worldview of the stars now, because a lot of scientists these days are taught that stars are fusion reactors and they do all this weird shit. But the truth is that the star is the luminous nebular cloud that gravitationally collapses and becomes a life-hosting world, or the planet. It's a completely different worldview, and it's a worldview based on understanding this kind of stuff. So those people who want to say it's pseudoscience, you guys are full of shit. Alright, y'all. I'm going to go ahead and read this book. There's lots of stuff in here. Wear resistance, functional and transparent housing, and hollow shapes. I mean, if you have design with metal, you design things with metal, you gotta know what you want to do with it. Talks about thermosets, UV light sources, when you set material, tungsten, carbide, molybdenum, different sintering temperatures for various metals. Check that shit out. There's a little diagram on that. I think I'm gonna study that as well, because like, I think the basalts that are inside of the surface of the moon are comprised of lots of titanium, and to understand how titanium functions too, that'd be really cool to understand. But anyways, I think I made this talk long enough. Today is March 10th, 2016.